In the new Plumber we have incorporated the pumping group device, which seeks to represent the existence of centrifugal pumping equipment in your projects. To create a group in the risers plan of your project, go to the Project tab and, from the Devices panel, click the Add Pump System button. The status bar asks you to indicate the initial node, which would be the suction side of the system, and the final node corresponding to the discharge side. Before reviewing the properties of this new group, you should know that, in this case, we have a single-family housing project supplied from an elevated tank, as you see in the installation of the roof level. For this tank, the average level of water required to guarantee the working pressure of the sanitary fixtures was determined in the automatic design. The corresponding value is approximately 9.9 meters, for which we have chosen the value of 10 meters, here in the scheme, as elevation of the inlet pipe, which, as you will suppose, corresponds to the pumping pipe arriving from the ground level. Thus, we have defined the inflow. Let's go to the source, that is to say, to the pumping group that we have created in the risers plan of this project. This installation has the system source, an underground tank and, of course, the pumping group. Thus, the station will be fed from the lower tank and will discharge directly to the upper tank. This tank capacity was defined based on 100% of the total water demand, as we have already seen in a previous video. And, in attention to the altimetry, we estimate that the minimum elevation of water in it will be -3 meters. For the purposes of the pumping system, the tank's outlet pipe will be its suction pipe. Like any other pipe in the program, it is possible to let its sizing take place automatically, as shown here. Certainly, for the purposes of head losses calculation, we have to specify its length as well as the required fittings. Well, and now, we present the properties dialog of the pumping group. As you see, it is made up of 3 tabs. The first one is the one that contains the basic or general information, necessary to define the type of pumping. You will see that we have the option to feed the group directly, in which case we must enter the suction pressure. And the one we have selected, fed from a tank, that is the recommended configuration for the proper pumping system operation. In this case we must select the tank, in our example the underground one, and also establish if we use the minimum elevation specified for it or if, on the contrary, we choose to introduce our own value. To do this you should deactivate this box and enter the desired value. Then you will see, on the right, the options available for the discharge side. In this case, we select the discharge to a high tank, for which we select the target tank, our tank in the roof level. We specify a filling time parameter necessary for the program to define the design or pumping flow. And, clicking this button, we will introduce the properties of the pumping pipe, leaving, as always, the automatic calculation option activated. Then we have the Pumping Pipes tab in this dialog. The idea here is, considering that the program assumes that each pumping system consists of one or more pumps connected in parallel, that you specify the characteristics of the suction and discharge sections of each pump. You must also select, from the program's pumps database, which one you want, so to speak, to try on the pumping pipe. And, finally, you must specify how many similar pumping pipes will exist in the pumping group. In this case we will leave 1. We have thus defined the pumping system. We are going to close here to redo the calculation and show you the contents of the Calculation and Selection tab. Once the calculation has been carried out without new features, we return to the properties of the pumping group. And let's go to the Calculation and Selection tab. In this box will be shown the values for the pumps selection, that is, those required by the pumping system and that can be useful to make the specifications for a pumping equipment distributor. Then, on the right, we have the table with the operating parameters for the chosen pump. That is, the real values. In this table the results of the system's characterization, presented in the graph in the lower part, are summarized. Here we have the resistance curve of the pumping pipe to the elevated tank. Let's modify its color and thickness to see it better. We see, in red color, the required operation point, that is, the plotting of the selection values up here. This will give you an idea of how well, or how bad, the selected equipment is working. And, finally, we see the characteristic curve of the pumping group, that is, the elevation of the water in the suction tank, plus the pumping height given by the pump model, minus the losses in the route, including those of the pumping pipes. The intersection of the two curves gives the operation point reflected in the table which, as you will see, is somewhat larger than the required one. The total height will be the piezometric head to the discharge of the pumping system. And, in the remaining columns, are the operating values for the pump assigned to the branch in question. The supplied flow is equal to the total since we only have one pump operating. This is the pumping height that will be supplied by the pump assigned to the flow rate pumped. And this the efficiency at which the equipment would operate. Here, to help you establish a decision, we indicate in parentheses the deviation of the operating point from the one with the best efficiency value of the pump model. In this case, being negative, it is indicating that the point of operation would be displaced about 2.5 points to the left of the point of best efficiency. And, finally, we have the net positive suction head required by the equipment for the operation point. This value should be compared with the available one here in the selection box in order to establish whether or not there will be cavitation in the installation. Of course, you could ask what would happen if two pumps like this operate simultaneously and in parallel. Certainly, this is not the best example, but let's make the change in the Pumping Pipes tab. Click OK to close the dialog and recalculate. And let's go back to our Results tab. Now you see the curves of one pumping pipe, and the two of them in parallel, with the point of intersection at 0.42 liters per second. Each pump will give 0.21 liters per second now, but you will see that the difference with the best efficiency point is too high to even consider this as an adequate solution. As you see, we think that we have put all the information you need to be able to establish if the pumping system will operate properly. The same information will be shown for the other types of pumping, that is, against the network or using hydro-pneumatic, as we will present in the next videos.